Department of Management Studies, we started in the year 2004, and we are a good 15-year-old department, and we are growing as of now.
One of the things we've been involved in is an executive MBA program, which is meant for people with a lot of experience, a huge amount of peer learning that's involved because the batch size is quite diverse.
DOMS IIT Madras has the culture of working closely with the industry, which enables nurturing leaders and entrepreneurs through a holistic and grounded learning experience.
We are extremely privileged to be collaborating with the other departments of this technical institution. We typically do courses in departments such as computer science, electrical engineering, humanities, and social science.
Technology bridged with business management, Tech MBA. This is first time in the history of IITs that we have started something like a Tech MBA program.
We also have government-funded projects which help the scholars in contributing towards building a better nation.
We're proud to say that many of our MBA students in the earlier batches have reached the CXO level as of now.
The Institute of Eminence scheme has been launched by the Government of India to empower higher educational institutions and help them become world-class teaching and research institutions. IIT Madras is proud to have been selected as one of the select institutes of excellence. As part of our commitment to the cause of fostering world-class research, IIT Madras has set up a number of research initiatives in diverse fields of contemporary relevance. Many of these initiatives will go on to become centers of excellence within the IIT Madras system. A total of
Hello and good day to everyone. Thank you for joining us today. On behalf of the Office of Global Engagement, it is my pleasure to welcome you to the 52nd webinar from the IRIS webinar series. My name is Richu George Philip, and I'm a part of the Office of Global Engagement at IIT Madras. The Institute of Eminence scheme was launched by the Government of India to empower higher educational institutions and help them become world-class teaching and research institutes. IIT Madras is proud to have been selected as one such institute of eminence. A total of 68 research initiatives belonging to 21 identified technology clusters are presently underway at IIT Madras. And as a part of these initiatives, the IRIS webinar series aims to showcase the innovative research being generated to various stakeholders like the students, researchers, industrialists, and policymakers. And from the Earth Sciences Technology Cluster, the research initiative presenting today is titled Atmospheric and Climate Sciences, led by Professor Sachin S. Gunte. The research at Laboratory for Atmospheric and Climate Sciences is primarily focused on the problems which are at the forefront of challenging earth sciences research. Primarily focusing on Indian climate research region, they try to understand how human activities perturb and affect the Indian climate system under various aspects. To introduce Professor Sachin, who is a principal investigator of this research initiative, Professor Sachin is a professor of civil and environment engineering at IIT Madras. He is an associate at John A. Paulson School of Engineering and Applied Sciences at Harvard University, as well as an associate researcher at Max Planck Institute for Chemistry at Mainz, Germany. Professor Sachin's research mainly focuses on role of atmospheric aerosol in Earth system science and human health. In his free time, he is an avid photographer. Thank you for being with us today, Professor Sachin. It is my pleasure to introduce the moderator for the webinar today, Professor Scott T. Martin. Professor Martin is the Gordon McKay Professor of Environmental Chemistry at Harvard University, with appointments in the School of Engineering and Applied Sciences and the Department of Earth and Planetary Sciences. Professor Martin is the Director of the Laboratory of Environmental Chemistry in the School of Engineering and Applied Sciences at Harvard University. His research focuses on research and engineering solutions to the major environmental challenges presently facing the world. Professor Martin is a long-term international collaborator of Professor Sachin's circa 2007. Thank you for joining us today, Professor Martin. We're very excited that you could be a part of this session. We also have a very distinguished panel and faculty from across various departments at IIT Madras today with us. We have Professor C. Balaji, Professor R. Ravi Krishna, Professor Shiva Nagendra, Professor Rajkumar Bala, Professor Anubhav Roy, and Professor Chandan Sarangi. A very warm welcome to all of you. And before we start, a note to the participants. Please use the Q&A to enter your questions and upvote questions that interest you so that Professor Martin can prioritize them later. Over to you, Professor Sachin.
Thank you, Richu, for the nice introduction and getting me going with that. So, good evening, everybody. I believe that my screen is visible and then I'm audible. Is that correct to assume?
Yeah.
Okay. So, good evening, everyone, and I'm glad to present very briefly the glimpses of the Laboratory of the Atmospheric and Climate Sciences as a part of this IOE, which I'm doing with my colleagues here at IIT Madras. I would start with this beautiful picture, which I obtained from the NASA Earth Observe Laboratory, where you see the western coast of India and then see this dust storm, which is heading towards the continental India. What I want to show out of this is that when this dust is over the ocean, you can see this strong contrast. And when it is on the surface, you do not really see such a strong contrast. So what it tries to tell is that we do have multiple ways that how these tiny particles, which is the prime focus of this research center or this laboratory, do affect the climate in various ways. This is just as an outline. I'm going to follow that what we as a 6 different collaborators do to this laboratory, but really very briefly will touch base upon this. Well, just to start with, I would like to dedicate this slide kind of to Professor Paul Cloudseeding, who I had an opportunity to be associated with during my Max Planck Day, who passed away this year, who introduced this term called Anthropocene, which is nothing but an analogous term which you used for the different epochs on the Earth. So what this term basically tries to tell us is that we are no longer living in an era which is not very strongly influenced by the human activities. I'm trying to find out this pen where I can find it, if I can at all. Anyway, so what you can see here is that in the Anthropocene over the last 400 years, you have increase in carbon dioxide, you have increase in methane, and then not only that, but you also have an increase in PM 2.5 concentration, which is the particulate matter less than or equal to 2.5 micron, which we also call as an aerosol. So in the sense that this is a very powerful term, which tries to tell us that what we are really going through at this moment. Just to come back to that, since we are focusing on the Indian region, why Indian region is challenging and unique? Well, there are multiple reasons, and one of that is the very distinct season. So if you really look the wind which is coming over the Indian region during monsoon season, it is mostly the southwesterly, bringing the monsoon rain. But the moment it is during the winter season, it is a very contrasting wind, which is northeasterly, and then it kind of takes out the outflow of the Asian pollution on the Indian Ocean, and then you can have the further repercussion when it really comes back during the monsoon season. In addition to that, if you look into this fact that the India has a very diverse land use pattern, it really starts from the glacier up in Himalayas in the Indian Himalayan region, and all the way down it can come to the Western Ghats, which is the hottest hotspot of the biodiversity across the globe. And then the third and most important is that India has an extremely diverse, very heterogeneous population. Like if you look into this Indo-Gangetic plain, which is very densely populated, and it has a very strong relation with the pollution. This is just as an AOD as a representation of a pollution, how you look through the satellite. Various areas which are densely populated indeed do have the very high pollution level. So this all you kind of put it into the blender and mix it, what you really get is a very complex phenomenon, very complex climate on the Indian region. Now coming back to the aerosol, which is more or less the focus of the Laboratory of the Atmospheric and Climate Sciences, these are the very tiny suspended particles in the atmosphere, which range from 1 nanometer to up to 100 micron. They could consist of sulfate, source, secondary organic matter, soot, mineral dust, so on and so forth. And then in addition to that, some of them could be biological in nature, which Professor Ravi Krishna is dealing with, which I'll present some time from now. If you look into the aerosols, they can either primarily emitted in the atmosphere or secondarily formed, and then they play an extremely important role as far as the cloud formation is concerned. And then clouds are important for us to get the rainfall. So clouds cannot be formed without the rainfall, and without rainfall, there would be no life on the Earth. So in a sense, we kind of owe our existence to the aerosol particles. So to briefly close this up, particularly for this slide, they do affect the atmosphere and climate and can have a severe impact on the biosphere and human health. Just to kind of bring it then, how do these aerosols are important and do affect the climate? Once these aerosols are up in the atmosphere, they interact with the incoming solar radiation. Depending upon their chemical composition or type, either they can absorb or emit it back into the space. That we call it as a direct effect. Clouds cannot be formed without the presence of aerosols. So the cloud do also further interact with the incoming solar radiation. So that's the semi-direct effect. And then in addition to that, what we now know is that the changing aerosol properties can perturb the cloud properties either by increasing their lifetime or changing their lifetime. And then depending upon the color of the cloud, which is then perturbed by the aerosols further, can we reflect these incoming solar radiation back into the space either by cooling or then absorbing the infrared radiation by hitting it. That's something which we call it as the secondary direct effect. Now, just to kind of summarize why we want to really focus on the aerosol cloud interaction, if you look into this figure, that the constituents which are shown here in red color, they tend to warm the Earth's surface, but the constituent down here, which are shown in blue, they tend to cool the Earth's surface. Now, in the error bar associated with these constituents, they are very small. It means that we fairly have a very good idea since 1750 how much these constituents have warmed the Earth's surface, because we have a very good baseline for it. However, for the aerosol cloud interaction, that this error bar itself is bigger than the estimate, which as it is translates into the direct estimate. So I can then go on to say that the confidence is very low in this estimate, and hence aerosol cloud precipitation interaction represents the largest uncertainty in the current and future understanding of the climate change. Well, how do we tackle it? Unfortunately, that our laboratory at IIT Madras or any other institute alone cannot really tackle this problem. Now, without going into the details of this flowchart, what it really requires, it requires the lot of different institutions collaborate very closely, and then it is a very interdisciplinary research area so that you could really generate good model data, you could generate laboratory data, field data, and then kind of put it into the different process model and regional model, and then finally put that data into the global climate model to really predict the climate uncertainty by the end of this century with as accurate number as possible, and we could go. As I just said on my previous slide, of course, that the collaborations are vital for the climate sciences. And then I personally feel very privileged to have been associated with the top-notch researchers in the world over the last almost 15 years. And Professor Scott Martin is here, as you can see. And then Professor Uli Groschel from Max Planck Institute, then Hugh Ko from Manchester, Peng at Georgia Tech Institute, who happened to be the former PhD student of Professor Martin. Now, coming to the objectives of this center, without going into this lab, without going into the details of this, more or less it is more focused on the Indian region, where we try to understand the atmospheric and cloud dynamics, gas phase and aerosol chemistry of the troposphere, then climate science impact, particularly the biosphere and cryosphere. But in addition to that, one of the major objectives which we are putting for this center is that we are going to aim, or we are already aiming for the excellent capacity building by the various programs which we intend to introduce. Now, just to give you the glimpse about that, what it is, very quickly, my research focal points that I work on the aerosol chemistry and physics, cloud condensation nuclei, that how these aerosols effectively form the cloud, bioaerosol, the health effect, and then the climate modeling. And then we try to achieve this by combining the laboratory field and model studies using the very advanced physical, chemical, and biological techniques, and then the high-end instrument. Just to quickly give you the glimpse of what we have recently done is that we published this paper this year in Nature Geosciences, which tries to unravel this mystery of the fact that why there is a low visibility in Delhi, why do we face this problem of the fog formation or the haze and smoke formation in Delhi. What we found is that unlike any other part of the globe, if you look into the chemical composition, PM 2.5 chemical composition or PM1 chemical composition, in Delhi it is more dominated by the chloride, which has a very high water uptake ability. So these particles will swell big enough under the high relative humidity conditions, bringing down the visibility. Where does this chloride come from? When we kind of try to compare the Delhi scenario during the Godi festival in Chennai, where as a ritual, the burning of the waste happens, what we realize is that, for example, when you burn the plastic, it releases the HCl, which then combines with the ammonia, which is readily available through the livestock and agricultural activities. And this is how it goes on to form the ammonium chloride, which kind of causes the further problems, which leads to the visibility degradation. Coming to the cloud microphysics modeling, which is led by Dr. Anubhav Roy, what he tries to understand as a part of this center is that we relatively better understand that how the aerosol particles are converted to the cloud droplets, but it is more complicated to understand how the cloud droplets are then converted to the rain droplets, because that is more governed by the collision and coalescence rather than the condensation and evaporation. So how he basically tries to address that issue is that he kind of takes the various models, like for example, Lagrangian dynamics, condensing droplets in homogeneous isotropic turbulent flow, then upscale it into the Stokesian hydrodynamics. Then he would again upscale it into the super droplet method, and then eventually go on to perform the direct numerical simulation for a given type of cloud, that how these cloud droplets are then being converted into the rain droplet. Coming to the most important part, again, related with the aerosol, which is the atmosphere-cryosphere interactions over the Indian Himalayan region, which is led by Chandan Sarangi. These aerosol particles, depending upon, again, their type and then the composition, once they kind of deposit on the glacier, they can enhance the glacial melting, right? And then, if you can see this paper, Professor Chandan has published like last year, which tries to tell us that the dust basically, rather than any other aerosol particle type, the deposition of the dust on the Himalayan region basically enhances the glacial melting. That's what he's going to lead in that. He's also interested to look into how does the pollution which is emitted at the urban scale, once it gets transported onto the rural region, how does it basically affect the different issues at the rural region? For example, how does the agriculture practically in rural region affect the urban microclimate? The other way around also, he's trying to kind of understand as a part of this atmospheric laboratory. If I go to the futuristic climate modeling, which is being led by Professor C. Balaji, where what he's basically trying to do is trying to look into the various aspects that how do we overall, enhance or improve our modeling capability. That's not in terms of the computational resources, but in the boundary condition, how do you really then assimilate the data. And then he's also kind of looking into the data-driven AI/ML hybrid models for the Earth system science. And one of the important aspects of this is the prediction of monsoon, which he is using by the data-driven AI/ML hybrid models. And then, as you all know, that the monsoon is very important for us. Not only that it brings the rainfall and the agriculture is dependent on that, but it is also equally important as far as the understanding related with the water resource management is concerned. One of the other aspects which he is also looking into by means of the climate modeling is that he's trying to understand that how the cyclones which have occurred in the past would behave under the various climate forcing scenario. This climate forcing scenario means that how much it is going to warm, let's suppose 1 Kelvin, 2 Kelvin, 3 Kelvin, how the cyclones are going to behave. One example which I'm giving here, which they have simulated for cyclone Varda, if you look into the under climate forcing scenarios, it is not changing the track, but indeed what you see the figure here on the lower left side, indeed the maximum surface wind which is going to occur under the different climate change scenario is going to be different for different scenarios. Air pollution management, which is very important for us. I mean, climate and meteorology is important. Now, this air pollution aspect, which is led by Professor Shiva Nagendra, where they try to understand the regional air quality modeling, then they try to put it into the cause-effect relationship, and they really try to understand the air pollution hotspot characterization, particularly related with the urban area. One of the recent papers which they have seen that how your PM2.5 concentration exposure to the human being really affects or really, how does it really look like when you are in an urban region? For example, if you are in an auto rickshaw, it is more. If you are in a metro, it is very low. So what I'm trying to understand is that they really try to look into the tiniest possible aspect as far as the urban pollution is concerned. What they do with this, they take all these data, they take these observations, and then eventually go on to develop an air quality management framework, which can then be transferred back to the policymakers so that you really get to go get the good urban air, which is not really affecting the human health. Coming to the second last one, that what Professor Ravi Krishna is doing, well, the bioaerosols are extremely important because unlike any other aerosol, depending upon where you are, irrespective of what their concentration is, they can cause you the different allergies. Now, what Professor Ravi Krishna is basically trying to do, he's trying to understand the various anthropogenic sources in the urban region from the municipal solid waste. And what he tries to do is that, let's suppose the 48% of the solid waste is biodegradable. So he tries to mimic that composting into the lab, where he tries to understand the fungal spore growth and emission, or the release from the common fruits and vegetables, which are more representative of the community usage. So he then tries to, how does he basically do that? Well, there is a very comprehensive setup he has in his lab, and then he tries to take the different fruits. If you want some fruit, you can always go to his lab, like apple and then watermelon, so on and so forth. And then not only that, he does the experiments with that, but he also tries to model the emission rates so that, you can accurately predict or you can accurately understand the emission rates of these particular bioaerosols in climate models. And lastly, but not least, the atmospheric VOC over the Indian region led by Professor B. Rajkumar, where he tries to apply the cavity ring down spectrometer to estimate the impact of VOCs and OVOCs on in general atmospheric chemistry over the Indian region. And one of the important aspects for this is that the VOCs are either a precursor for the formation of the secondary organic matter. So if we understand the VOCs in better, we would be able to understand the mass burden of the organic matter much better over the Indian context. And then these aerosols, as I have shown, are very important for us as far as the climate understanding is concerned. This is just one picture from his lab where you can see this nice cavity ring on spectrometer, and all these aspects he really tries to supplement with the various modeling. Well, just to summarize this now, we have this region with the Laboratory for Atmospheric and Climate Sciences, where we would like to really see that it grows into the full-fledged center, where we not only focus on the research, but then also on the capacity building. That's really very important part of us. And then how you can be a part of this? Well, we have this MS, PhD, and postdoctoral fellowships. You can always write it to us. We are actively looking for the collaborations because, as I say, that as far as the climate science is concerned, it is the area which requires the most collaborations from the diverse areas of the research. And then we are also doing the part-time campaigns and association. And one of these parts is that we have recently established a high-altitude laboratory in Munnar, where we are currently doing a lot of measurements. If anybody wishes to visit it, if you want to perform any sort of a measurement, please do write us, and then we would be very happy to facilitate this for you. So with this, I would like to thank you, and I hand it over to Professor Martin then. Thank you very much.
Okay, Professor Gunther, thank you very much. Wonderful presentation. I'd certainly like to congratulate you and your colleagues on your wonderful Center for Atmospheric and Climate Science. It's a real accomplishment to get that up and going. As you'll remember, we've been collaborating for 15 years or so, first in South America in the Amazon, and then in Europe, and then in your visits to Harvard, problems related to United States. And so I'm really excited now that you've focused on the Indian area with your center, and it's a real accomplishment to you and your colleagues to now have that center going with that focus to really focus your wonderful mind and efforts on the important problems India faces today and how those problems will evolve in the future and what types of things decision-making governments might make so that those problems go in the direction of being less of a problem than more of a problem. So really congratulations on all of that. You know, I wonder if you could just share with us, we've collaborated across all of these continents and problems, and now with your focus back to your home in India, how do you maintain all of those collaborations? You must face a lot of challenges, and there must be a lot to manage there. Could you comment on that?
Yeah, I mean, that's a very interesting observation, Scott, that as you are always known to make some interesting observations. So particularly with this collaborations, right, this is really the organically grown collaboration. It's not that like, we just identified the topic and then approach the people, right? We have been doing this for last 15 years, as you have rightly said, right? So we probably have had this rapport, like we do really understand each other as a researcher, of course. And then there is a very long history of the proven track record of a quality research, which really is visible from the publications which we have had so far, right? So it is indeed, as I always say, that it is not difficult to initiate a collaboration, but it is more difficult to sustain that because you always have to match up to the expectation of the people which you look upon. And that's really the critical part of it. But having said that, it is the critical part of it, it really keeps at least me going that I should always be doing the best as far as the collaborations are concerned.
Very good. Now I'm looking at the Q&A questions. There are a number of really excellent questions. I think the first one is, as you mentioned, the Indian, the shift in the winds across the plain between seasons and the monsoons. And the question in there is, how might that change in the future? How might the winds change or the monsoon season change? And what's your center doing to understand that and address that type of very important question?
Yeah, so I would take that question, and if required, Professor C. Balaji may join in afterward. We do not really believe that this wind would directly change, right? But what we do expect that the intensity and the frequency of these different events which are associated with the wind change may happen, right? Let's say, for example, with the monsoon, we do know now is that although the total amount of rainfall which we receive over the Indian region as a monsoon season, that has largely remained constant, but that this temporal and spatial distribution have changed very largely, right? So I do not really believe that these winds would directly change, that they would reverse exactly, but indeed that, there are a lot of other factors associated with the intensity and frequency that would definitely change.
Another very important question in there is the balance between agriculture and population, meaning the question comes up as the Indian population continues to increase and use more arable land for housing and so on and so forth, that actually reduces the land available for agriculture and food, and then layered on top of that are whatever shifts there are in rain patterns. Well, how do you see possible, let's call it, threats to Indian food supply and agriculture under these changing pollution and climate conditions?
Yeah, Chandan, would you like to take that question?
Yeah, hello.
Yeah, go ahead, Chandan.
Yeah, means first of all, like we are seeing a lot of extreme events which is happening, and we are trying to as extreme event is definitely in the nexus of whole climate, water, power, and food. Like extreme events, if we cannot predict them, then they definitely affect some linkage of this nexus, and eventually it will affect our food supply. That is definitely one. And when we talk about these extreme events, we are still not clear what is driving it in our local scale. Is it the change in the climate, or also the heavily pollution we are facing it, right? And those questions are inherent, and while we are trying to solve our questions, we'll come up with answers on these respects. Yeah, thank you.
There are a number of interesting questions in there about clouds and what we might call cloud microphysics, or a cloud is a suspended water with many different particle sizes. But one of the interesting questions there, and it says, Dubai is trying to change its rainfall patterns. What about similar, and China has a program for that. What would you see as the role of, and the question is there, is artificial rain generation, silver iodide, meaning if rain patterns are changing, can we have a human adaptation that tries to control those rainfall patterns? Is that a good idea, a bad idea? Is it possible? How does your center think about those questions and possibilities?
Would you like to add in that, Scott, if I may say?
My general point on geoengineering, meaning if we're changing climate, and we're not able to stop that climate change, would we try then to artificially tinker with the planet? And given that it's such a complex system, we hope we never come to that point. But one of the Nobel Prize winners, Paul Crutzen, in 2007, wrote an important paper. He got a Nobel Prize for ozone, and he said, the ozone hole, and said, listen, unfortunately, we're to the point that we seem to be, governments are not responding and climate is moving, and we might really have to consider some geoengineering and it is, how do you say, an intriguing possibility, but we really need a lot of research on it beforehand. Yes. To make sure that in the effort of trying to do something positive, we don't actually end up doing something negative. Did I see there also, Professor Sarangi, that you wish to comment?
Yeah, means I also believe in these lines. Like, so in Indian clouds are like mixed phase clouds, and a lot of development happened in the warm phase under a very convective updraft, which are actually very complex systems. So when we say about Dubai, or we say about cloud seeding experiments in US, those are mostly focused on the ice clouds, and they have done a lot of experiment and have understood it. And in our context, we we need to do that amount of research to understand the first 3 kilometers of the atmosphere when the clouds are initiating. The exact point where we want to modify it, that is the crux. And as you say, it's way away. But as the thought of the this lab, we are going in that direction where we are including more observations, we are including more experiments. And I think this is the right way, and it will also feed back to a lot of governmental policies that is going to happen in India. Recently, we had a very big success campaign, KIPEX, which brought us for the first time some of the key measurements of aerosol and cloud in the bottom 5 kilometer of atmosphere, which I think is very key, and more understanding and research in that can help us to address this question. Yeah.
There are understandably questions about human health and pollution in Delhi. Just for context, the 1930s in Los Angeles, when we were learning about air pollution, during those 4 or 5 years in Los Angeles, the air pollution was actually worse than it is in Delhi now. For folks who don't know, Delhi unfortunately has the present title of the most polluted city on the planet, and so many people live there. Can you comment on what your center is doing to learn more about the problem and contribute to a solution?
Yeah, I mean, see, Delhi, as you say, the Delhi is a very complex topography, right? And then the climate-wise also it is very complex. So we need to have a very proper solution that where we really control the emission of the particle. I'll try to substantiate that with an example. So let's say if you take the area of Delhi, and then whatever that vehicle density you have in that area, if you bring it to the southern part of India, it will not be that polluted. So we need to really understand that because the winds are very kind of, the wind speed is high and the relative humidity is high, so on and so forth. And then in the southern India, it is not really landlocked, but Delhi is really landlocked. So what it does is that we unless we really go back and step back and say that what are the controls which we bring on the emissions, that is something going to be the key. Then the number two is that, as I showed, that the formation of the secondary aerosols, right? We do not really know how much is the burden of the secondary organic matter in Delhi. So unless we kind of bring back that particular closure, we would really not know that what measures we need to substantially take to kind of bring that down.
I see that we're starting to run short on time here, but there's one very important question out there that I hope a couple of people on the panel could comment on as kind of our take-home message and go-away message. And that is, people are asking, wow, I'm excited about what I've heard today. How can I get involved? What can I do in my own life day to day to move in positive directions related to atmospheric science and climate and future of India? What can I do, or what should I do on a personal level? It's kind of a very big question, but I think it's a good one to kind of start to finish up on. If people on the panel have a couple of comments on how members of the audience can continue from here and be more involved in these questions.
We can start with you.
Well, my continuation is I'm looking forward to a robust interaction with your center and possibility as COVID ends to come and make a visit and be even more part of it. That would be very exciting to me personally.
So maybe we can have some other comments from the other colleagues of mine, like Professor C. Balaji, Ravi, Rajkumar, anybody. So Richu, just before that, Richu, so is there any hard stop for us, or we can continue for another 5 minutes or so?
Of course you can. We don't have a hard stop. You can continue, no issues. And you have a lot of questions from the participants as well, so please go ahead.
No, that depends on Professor Martin, how many he wants to take.
Yeah.
Yeah, so good evening. So hello, Professor Martin, good to see you. So basically the take home message for somebody who's viewing this would be first understand as a layman, get to know the difference between weather and climate. What is weather and what is climate? And many people are talking about climate is changing, climate is not changing. We are endowed with the mind, the brain. So first analyze yourself, look at the data properly. So separate the science from the fiction and see it for yourself, and see if in small ways how we can contribute to sustain this planet. I stop here. Thank you.
Ravi?
Yeah, thank you. One of my, I think a lot of questions that come up in classrooms and also in general forum is that how do we solve the problems? And I believe that to solve a problem, you need to understand it properly. And the case in Delhi has been going round and round and trying to find out if it is the aggravation in Delhi is because of external factors which are meteorological, which are topographic, and so it's like a diagnosis of a disease. So if you're sick, you go to a doctor, and the doctor just gives you a bunch of medicines without understanding what's going on. You're just doing trial and error. It may do bad things to you. So the diagnosis is one part of the system. When you do a correct diagnosis, then you can design an appropriate solution, which is, and especially in cases like India, our resources are limited, and so understanding the system is very key for us to optimize, come up to an optimized solution where we don't have enough money to keep throwing around for trial and error solutions. So we can adapt from other places which have already done these studies, but certain things are very local, very specific to India. So we must understand this, and that I think the overall change has to occur from top down to understand problems first and build technologies for us to, things like fast sensors and sensor networks, and even the science behind it, the physics behind it, the chemistry and the modeling behind it. I think there's a lot of focus on that. It's coming up now, and I think it is far more important for us to continue on this direction.
So, Richu, Professor Martin, do you want to take another question or so, something, or anybody wants to come in?
I think we've summarized largely what's in the Q&A now and given people a really robust sense of what your center is doing. And we've heard a number of perspectives that have been very illuminating from the different panel members. So I'd like to again congratulate you and your colleagues. You've got a lot of momentum, and we'll be looking forward to seeing how it develops further and the center's contributions to the problems that India faces under these changing conditions of climate outside the borders that kind of put a forcing on India, and then things within India that India can control related to air pollution and energy matrix, and how your center will continue to be a robust source of knowledge and advice in the years to come. So congratulations again, and thank you everybody for joining for today's presentation.
We hope to see you, COVID restriction permission, we hope to see you on the IIT Madras campus soon then.
I'd look forward to it, yes.
Thank you, Professor Martin, and then thank you everyone. Good night.
Thanks a lot for being with us, Professor Martin. It was wonderful to have you here with us today. Thanks for taking time off your schedule and, agreeing to be the moderator for the event today. Thank you. And thanks to everyone on the panel for being with us. And thank you to all of the participants. And good luck to the research initiative. Thanks.